Today I want to talk about a cute little book on foundations of analysis by Edmond Landau, which is a real masterpiece, and according to Landau, a student can finish reading the book in 2 days. Today, no decent author of a book on foundations of mathematics will fail to refer to Landau's book. It is the Bible in the subject of construction of number systems, starting with Peano's axioms and ending with the construction of real numbers, building the integers and rational numbers on the way. The construction of complex numbers from real numbers is a small step. Landau explains the rationale behind authoring this book, discussing the logical pitfalls he had to overcome despite being a very careful and eminent mathematician of his time. In his preface, he gives very useful advice to students as well as teachers about studying and teaching the foundations. This book is very pertinent for us and will ease the process of understanding the proof of recursion theorem. Edmond Landau was born in 1877. He taught at the University of Berlin and University of Göttingen. Landau was not too happy teaching calculus courses because his students lacked the necessary foundation material to understand rigorous proofs of theorems like the mean value theorem, the Rolle's theorem, intermediate value theorem for continuous functions, and many others in their study of calculus. Even his colleagues in the department found it difficult to bridge the gap. He wrote several books. The most well-known perhaps is Foundations of Analysis, an English translation of his German book Grundlagen der Analysis, which was published in 1929. The Foundation of Analysis is about 150 pages in length, and in the preface he writes that it took him more than a decade to prepare the book. Let me now draw your attention to some of the important points which Landau is making in his preface. There are two prefaces, one addressed to students and the other to teachers. In the preface to students, he writes, and I quote, "Please forget what you have learned in school. You haven't learned it. Please keep in mind everywhere the corresponding portions of your schoolwork. You haven't actually forgotten them." Well, the point Landau is making is this: none of the rules of arithmetic which we have learned spending years in school are going to change. The house will not crumble. We are only strengthening the foundations. We are learning a new language to give a meaning to the old language. His advice as to not forget what we learned in school is because the old knowledge will guide us to put the laws of arithmetic on a solid foundation which will never crack. Yet, he tells us to forget the old stuff so that we do not accidentally trip ourselves. It is this dual path which we have to follow and keep on doing mental acrobatics, which makes it appear that the construction of natural numbers is difficult. But take heart. Once you understand the recursion theorem it will be smooth sailing. After that, till we come to the construction of real numbers, when we will make a quantum jump to get into the next orbit. Quoting Landau again, after the first 4 or 5 rather abstract pages, the reading is quite easy if, as is actually the case, one is acquainted with the results from high school. End of quote. I will repeat only my advice given in the previous video. Understand the recursion theorem very well. Go slow first and you will be amply rewarded for your effort. Like a mother who goes through an excruciating pain during childbirth but forgets all that, seeing the newborn, you are witnessing the birth of numbers and the rest of mathematics. You will also forget the pain of abstract mathematics once we are done with the recursion theorem. Landau next justifies why he wrote the book, despite nothing new in it, and I quote, "One reason for my doing so is that this book is written when my daughters have been studying chemistry at the university for several semesters already and think that they have learned the differential and integral calculus in college. And yet they still don't know why x times y is equal to y times x. There are 73 definitions and 301 theorems in Foundations of Analysis. He rarely, if ever, uses the natural numbers 2, 3, 4, etc. as we know them from elementary school. And there is a good reason for that. He wants to be very careful that there is no circular reasoning. When one is trying to develop the number system and their arithmetic properties, we must be sure that we accidentally do not use any facts that are so familiar to us from our early school days. Despite Landau's very careful treatment, one of his colleagues found a logical gap which fortunately was not serious and could be fixed easily after Landau learnt of a very simple proof of recursion theorem from Dr. Kalmar. His other well-known book is on differential and integral calculus, where he develops calculus very rigorously. I recommend this book very strongly, and you can pursue the subject after I complete the first phase of development up to real numbers. I will also be using this book in the next phase. Then he has 3 volumes in German on number theory. Next, let me mention a few quotes from the preface to Teachers, where he justifies writing a book on a subject where he essentially did not have anything new to say. And he also gives reasons as to why this foundational material should be taught at the university, even to students who study mainly for applications. I quote, "While a rigorous and complete exposition of elementary mathematics cannot, of course, be expected in the high schools, the mathematical courses in colleges and universities should acquaint the student not only with the subject matter and results of mathematics, but also with its methods of proofs. Even one who studies mathematics mainly for its applications to physics and to other sciences, and who must therefore often discover auxiliary mathematical theorems for himself, cannot continue to take steps securely along the path he has chosen unless he has learned how to walk, that is, unless he is able to distinguish between the true and false, between supposition and proof, or, as some say so nicely, between non-rigorous and rigorous proof. End of quote. Again, quoting Landau, now in the entire literature there is no textbook which has the sole and modest aim of laying the foundation in the above sense for operations with numbers. The larger books which attempt that task in their introductory chapters leave, consciously or not, quite a bit for the reader to complete. End of quote. Further he goes on to say, I quote, "It is not without hesitation that I publish this little book, because in so doing I publish in a field where, aside from an oral communication of Mr. Kalmar, I have nothing new to say. But nobody else has undertaken this labor, which in part is rather tedious." End of quote. Finally, to his critics in the department, he has this to say, I quote, "And of these honored friends and enemies, none would have doubted that everything needed could be found in, say, my lectures. I too believed that. And then the following gruesome adventure happened to me. My then assistant and dear colleague, privat docent Dr. Grant Jot, was lecturing on the foundations of analysis, and using my notebook as a basis for the lectures, he returned my manuscript to me with the remark that he had found it necessary to add further axioms to pianos in the course of the development, because the standard procedure which I had followed had proved to be incomplete at a certain point." Landau is modest enough to acknowledge that there were three places where the objection came in, and they were justified: in the definition of addition, in the definition of multiplication, and in the definition of summation and products. In summary, Landau has to say that it is a very tedious task to go through the construction of natural numbers, but one must go through it because there are many logical issues involved. I will conclude by reminding what Landau's advice is. Forget what you have learned in school because you haven't learned it. At the same time, don't forget what you have learned, because that will be a guiding torch for us. I hope that this video makes the transition to the proof of recursion theorem very enjoyable, and in the next video you will see a motivated proof of the recursion theorem And once you see that, you will realize it is very, very simple. The technical details of the proof of the recursion theorem will be in the following video. Thank you.